Welcome to Computational Genome Biology YouTube channel. In the first half of the 20th century, acute paralytic poliomyelitis swept across the globe. The virus predominantly struck young children under the age of 3, and in its most severe form, it led to life-threatening respiratory failure. In the United States alone, the 1952 epidemic paralyzed 58,000 people and claimed 3,000 lives. The sheer panic inspired by the disease, often called the crippler, drove governments to extreme measures. Entire public spaces were shuttered, and some cities even resorted to spraying residential neighborhoods with the chemical pesticide DDT in a desperate attempt at eradication. That terror finally subsided with the rollout of the Salk and Sabin vaccines in the 1950s and 60s. These mass vaccination programs effectively eliminated major outbreaks in the Western world. As the decades passed, society moved on. The iron lungs were packed away, and the severity of the illness faded from public memory, replaced by a collective assumption that the polio problem was permanently solved. But while the acute outbreaks were stopped, this amnesia blinded us to a looming crisis. Millions of aging survivors were walking around with a hidden, delayed cellular toll from that initial infection. Today, there are an estimated 10 to 20 million polio survivors worldwide, and after living with stable health for decades, a massive portion of this population is reporting a sudden, mysterious physical decline. Medical professionals classify this specific neuromuscular disease as post-polio syndrome. It typically strikes between 25 and 40 years after the original viral infection. Patients experience a distinct cluster of debilitating symptoms. They report progressive new muscle weakness, an abnormal exhaustion after minimal exercise, and a visible loss of muscle mass or atrophy. Diagnosing this condition requires strict criteria. A patient must have a documented history of acute paralytic polio, followed by a minimum of 15 years where their neurological function remained completely stable before these new symptoms appear. This delayed onset reveals an unsettling reality about the virus. The childhood infection left behind a biological time bomb, hardwired into the nervous system and primed to detonate decades later. To understand how that delayed collapse happens, we have to look inside the central nervous system. All movement relies on the motor unit, a core functional system made up of a single motor neuron in the spinal cord, its branching axons, and the individual skeletal muscle fibers those branches control. During the acute polio infection, the virus invades the spinal cord and specifically targets those motor neurons. When a neuron dies, its connected muscle fibers are orphaned. They lose their link to the brain, resulting in complete paralysis of that muscle group. But the human body attempts a remarkable repair. If the patient survives, neighboring motor neurons that escaped the virus sprout new, extra branches. They reach out and adopt those orphaned fibers, reconnecting them to the nervous system. This hack creates what scientists call giant motor units. Because a single surviving neuron is now carrying the workload of its dead neighbors, these newly formed units can grow up to 20 times larger than a normal motor unit. This aggressive rewiring successfully restored clinical strength, allowing patients to walk again. Yet it left them with an irreparably warped, heavily burdened neuromuscular structure. This brings us to the core biological mystery of post-polio syndrome. Why do these massive, successful motor units function perfectly for 30 years, only to begin failing in a patient's late adulthood? The most prominent explanation is the overuse theory, also known as the metabolic theory. It argues that a single motor neuron simply cannot sustain the extreme metabolic demands of powering 20 times its normal muscle mass indefinitely. Under decades of continuous strain, the exhausted neuron starts to falter. It gradually loses the ability to nourish and maintain its furthest axonal branches, causing the adopted muscle fibers at the edges to slowly disconnect and die off once again. However, another compelling idea is the inflammatory theory. This proposes a dormant, localized threat hidden within the tissue itself. Researchers have found elevated inflammatory markers in the spinal fluid of survivors. The theory suggests that mutated viral RNA particles from the childhood infection remain dormant in the central nervous system, eventually triggering a chronic immune response that actively degrades the surrounding nerve endings. Whether the cause is a slow mechanical burnout from decades of overuse, or an awakening immune response attacking old viral ghosts, the result is identical: a steady, irreversible draining of the survivor's physical power. When we zoom out from the cellular level, this slow drain creates a severe functional crisis. Healthy aging adults have built-in physiological strength reserves, but post-polio patients are operating at their absolute biological maximum. When they lose strength, they lose mobility immediately. Because the original 1950s virus predominantly attacked the lower extremities, this new wave of muscle weakness directly undermines a patient's ability to walk, stand up from a chair, or safely navigate stairs. This lower limb weakness combines with profound post-exercise fatigue, extreme cold intolerance, and severe joint pain. Together, these symptoms create a perfect storm for physical accidents. Take a look at this chart contrasting fall rates. It shows that an alarming 50 to 84% of polio survivors suffer at least one physical fall every single year, a rate drastically higher than the baseline for the general aging population. For a vulnerable population that frequently suffers from reduced bone density, the trauma of these falls is severe. Over a third result in bone fractures that require immediate emergency medical attention. Beyond the immediate physical trauma, the resulting fear of falling creates a crushing psychological burden. Nearly 95% of fallers develop a paralyzing anxiety that initiates a vicious cycle, where survivors actively restrict their own movement and surrender their social independence to stay safe. While the history of the polio vaccine is a medical triumph, we can no longer relegate the disease to the past. The medical community needs to shift its focus toward comprehensive, longitudinal research into the active cellular failures happening right now. Decoding these specific biological triggers enables the development of targeted medical therapies and individualized fall prevention programs to protect millions of aging survivors. Thanks for watching. Please like and subscribe Computational Genomic Biology YouTube channel.